Okay. So to recap for you guys, and because I just remembered to start the video, we started with our polynomial function. It's all factored. We found our zeros. We're ignoring the imaginary zeros. The real zeros we ended up putting onto a number line. Spacing is not important here. Just get them in numerical order. That is important. And then for each of our functions in our original, for each of our factors in our original function, we drew a blank set of parentheses in here. So what I'm going to do now is I'm going to go through and I'm going to figure out for each of these, there are 16 blank parentheses. I need to put a plus or a minus in each of them. Okay, this is kind of time consuming, but there are a couple shortcuts that I'm going to show you involving the spaghetti in just a second. So let me show you the long way first, because some people prefer to do it this way. So what I'm going to do is I'm going to focus my attention on this x plus 5. I like to go factor by factor. That's going to match up with the first set of parentheses in each of our regions. And what I'm going to do is I'm going to pick a test value for x in each of my regions. This first region here goes from negative infinity to negative 9. Someone give me a value of x that falls between negative infinity and negative 9. Negative 12. Negative 12 is my x value in that region. Well, give me a test value between negative 9 and negative 5. Negative 6. Give me a test value between negative 5 and positive 2. What is it? I'm going to go 0. Thank you, though. I always pick 0 if I can. 0 is an easy number. And then between 2 and infinity, 10,000. I'm going to go 10,000. I love a million. Actually, a million is even better than 10,000. I don't have enough space to put all 6 of the zeros. I got room for 4 though. For 10,000. I like your style though. We'll pick something big. Go big, right? All right. So here's the idea. I'm going to take my test value and I'm going to plug it into this factor and determine if it makes that factor positive or negative. So if I put negative 12 in for x here, is this factor going to become positive or negative? Negative 12 plus 5 is negative something, right? It's negative 7, but the 7 doesn't matter. It's the positive or negative that matters. All right, go to your next region and take negative 6 and plug it into that same factor. Negative 6 plus 5 is a negative number. Negative 1, I think, but it doesn't really matter that it's negative 1. All we care about is the fact that it's negative. Our next region, we picked 0. Plug 0 in here. 0 plus 5 is positive. And then plug 10,000 in here. 10,000 plus 5 is definitely positive. So we filled out that first one. Okay. Now, there is a trick to this. There's a shortcut that makes this way, way easier. Would you guys like to see the shortcut? All right, so here's the shortcut. This is why you got your little piece of spaghetti. So x plus 5, the dividing line for this factor is at negative 5, right? Put your spaghetti down at negative 5 on your number. That's your spaghetti wall, your pasta wall. Negative 5 is the dividing line because everything, any x value to the left of negative 5 is going to give you what type of answer for this? A negative answer. And anything to the right of negative 5 is going to give you what type of answer? A positive. So we didn't actually need these test values. We could have just put a negative in both of these spots to the left and a positive in both of these spots to the right. That's the shortcut. Okay. Let's practice that shortcut with x plus 9. I'm skipping the x minus 2 for right now. So let's focus on the x plus 9. That's going to be our third factor in each of these. Put your pasta wall up at the important value for x plus 9. Where is it going to go? X plus 9. That's going to go, where's my pasta wall going to go on my number line? At negative 9. And we know that anything to the left of that wall is going to make that x plus 9 negative, right? So for all of your factors to the left, go ahead and put a negative. And then for any value to the right of negative 9, that factor is going to be positive, right? If I pick something bigger than negative 9, it's going to make this thing positive. So for all these regions over here to the right, that factor is going to be positive. See how that's a little bit faster? You don't have to actually physically plug in the -12, the -6, the 0, and the 10,000. You just think about everything to the left is going to be negative and everything to the right is going to be positive for that factor. Now the x minus 2 is different because of the square on it. Say that louder. Isn't it just going to be positive every time? X minus 2, and we take the answer and square it. Isn't that always going to be positive? Except for one value. Some 2 is going to be equal to 0. We don't have to worry about that because that's not in a region, is it? It's one of our boundaries. So you think that all of these are going to be positive? I agree with you. Do you guys see why they're all going to be positive? Because it's squared. Anything that's raised to an even power is always going to end up positive, or 0. But if it was 0, it would be one of our boundaries. So these are all going to be positive for this one. Excellent. We only have one more factor to deal with. Someone think through this. There's a little shortcut for this one too. X squared plus 4. All positive? For any value of x, that's going to be positive? We're only dealing with numbers on the number line. So yes, true, unless there's an I, but number line numbers aren't going to have an I. So always positive? Actually, there's no way this can end up being 0, can it? If we're dealing with real numbers for x, it's always going to be positive. So these are all pluses too. By the way, that's why we had imaginary answers, because this never crosses the x-axis, right? So it does not have any real zeros, because real zeros would have to be x-intercepts, and this has none. Why x squared plus 4 is always positive? Yeah, so if we're talking about real numbers, if I take a real number and square it, I can get 0 or I can get a positive answer. I'm never going to get a negative out of the x squared. Agreed? And the smallest thing I could get is 0, but I'm going to add 4 to it. So I can't even get a 0 out of that thing. Are we good? Thanks for the question. All right, any questions so far? So we've gone factor by factor to fill out all these pluses and minuses. We've got a couple shortcuts. The pasta wall helps. Okay, that definitely speeds things up. And there's an even faster way to do this that I'll show you in just a minute. Any questions before we move on, though? Now, our purpose in doing this is to come up with an overall sign for each of these regions. I want to know in each of these regions, is my function positive or negative? So you found a sign for each of these factors. Remember that these factors are all going to get multiplied together. So if I take a negative number times a positive number times a negative number times another positive number, what kind of final answer am I going to get? A positive or a negative? Negative times a positive is negative times another negative is positive. Positive. That whole region is plus. And this region right here, negative. And both of these regions out here, I think, are going to be the same because it's all positives, right? Plus and plus. And one final thing, I meant to do this at the beginning, but at least I didn't forget altogether. What is our function going to be doing at -9? It's not positive, it's not negative, it's crossing, it's equal to 0 here. And at -5, our function is equal to 0, and at 2, our function is equal to 0. And I want you to write those in. That's not, some people will be like, well, obviously it's equal to 0 because those are the zeros. In a moment, we're going to do this with rational functions, and some of them will be zeros, but some of them will be asymptotes. So it's good to keep in mind that it's equal to 0 there. All right, I'm going to show you how to use this, and then I'll come back and I'll give you the ultimate shortcut, which some of you may have figured out already, which has to do with, well, we'll figure out how to use it first. So you're you're not going to see a problem that looks like this in your homework. What it's going to look like in your homework instead is it's going to say x plus 5 times x minus 2 squared times x plus 9 times x squared plus 4 is greater than or equal to 0. Solve it. And you're going to do what we just did here. You're going to create a sign chart. And then you're going to use the sign chart to come up with your final solution. Let's use interval notation. I think this will be easiest. This little guy is called epsilon, by the way. It's kind of like the equal sign if you're dealing with intervals rather than specific numbers. It's kind of an E, sort of a curvy E, or a sideways shaped U with a line up the middle. So greater than or equal to 0. So let's go through our regions. Is this region greater than or equal to 0? It's positive, right? So we should include that in our solution, right? It is positive here. Positive numbers are greater than or equal to 0, correct? So greater than or equal to 0, we're thinking with greater than or equal to 0, we're looking for pluses. And we're also looking for where it equals 0. We need to pay attention to that. So in this region, yeah, so let's include that. Negative infinity, which gets a parentheses automatically, comma, up to -9. Now, should I do parentheses or square bracket around that 9? Greater than or equal to 0. It does equal 0 at -9, so square bracket. And our little union symbol. What about this region from -9 to -5? Nope, that's negative. Negative numbers are not greater than or equal to 0, so we'll leave that out. What about this region between -5 and 2? Yeah. Now, -5 for sure. -5 is getting a bracket or a parenthesis? Bracket. Now, do we need to actually cut it off at 2? Because we've got another region here that's also positive. We don't need to cut it off because there's no breaks, right? It's greater than or equal to 0 here. It's greater than or equal to 0 at 2. And it's greater than or equal to 0 all the way to infinity. So we can just take this straight to infinity. Someone out there is wondering, if I wrote this on a test, would you count off any points? What do you think? Same thing, right? It's a little more, it's overly complicated. I'd say it's not simplified, but it's correct, isn't it? So I would say no, I'm not going to count off for that on our test. Okay, but don't be surprised if a future math teacher, professor is like, no, that's not simplified enough. Okay. All right. So we have solved that inequality. Now, what if I gave you the same exact thing? And I'm just gonna, this is my symbol for the same exact thing. But instead of greater than or equal to 0, it said strictly greater than 0. Could you write a solution for me then? Why don't you try it? Try it on your own. It's going to look kind of similar to that. Some minor differences. This time we're not going to include anything where it's equal to 0, only where it's greater than. So just the positive regions, but not those boundary points in between. Try it on your own. I'm going to write the solution up here, and you can look up here for a hint, but don't just copy this down. Try it on your own. Positive. Are you finding this time that we have to use all 3 regions? we can't get away with combining these together because there is a break in between. We're not going to include 2 because it's not part of the solution. We're not including 2 because it's equal to 0 at 2, which is not greater than 0. So there is a break. I can't just go straight from negative infinity or -5 to infinity because there is a break here. So I need 2 separate regions to get me there. Where here I was able to combine it together because this was greater than or equal to. And if you're feeling good about that, I'd like you to try it the other 2 ways also. Try doing blah, 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 less than or equal to 0, and blah, 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 strictly less than 0. See if you can come up with solutions for those 2 also using your sign chart. And again, I'm going to write my solutions up here, but please try it on your own. Oops. That's a mistake. Mustaches. 5 ways mustaches. Yes. No, that one's a little simpler. Once you get those down, have a look at my answers and see if you've got questions. So when we have a single value that's not like an interval, not like from here to here, if it's just a single value, we use these. They're called braces, I think is the proper name for them. Those sine wave mustaches is what I call them. Shift bracket. Do we see why we had to include 2 this time around for this one? Because it's equal to 0. And that's why I think it's useful to write equal to 0 underneath it. Greater than or less than or equal to 0. This has to be part of our solution. The -9 and the -5 also have to be part of our solution, but we took care of that with the square brackets. We had to throw the 2 in though as well because it wasn't part of any interval. All right, does this look kind of familiar? Have you done something with sign charts before? Okay. There's different ways to do these, and I'm about to show you one that's even faster than this. That's particularly useful for polynomials, and you can use it for rationals as well. We're going to do an example with a rational as well. Can you guys show me where you're at right now on your thumb meter? How are we feeling about this? Okay, so I'm seeing learning phase between kind of 50% and 100%, somewhere in there. That's good. That's good. If you've got questions, if you're below 50% right now, then just give me attention. We should have some time later on. Okay. How can we check our answer on these? We could take this thing and plug it into our graphing calculator. We'd see a graph. What we would be looking at in particular on that graph? Yeah, where it's above the x-axis and where it's below the x-axis. We should be able to verify our sign chart by looking at the graph. In fact, making the sign chart would be super easy if we had a graph in front of us, which you will on the test. You'll have your graphing calculator and you'll want to use it to check your answers. However, I do expect to see your work for doing a sign chart in one of 2 ways, either just like we did here, and you don't have to pick the test values. The test values are useful sometimes, but if you understand what we were doing with the pasta wall, you don't have to do the test values. but I want to see these individual pluses or minuses, or I want you to do it the way I'm going to show you in a second. So here's the fast way for those that are interested. Now, I'd say if you're hanging out at like 50% on the thumb meter right now, see what you think about this. But maybe stick with, if I weren't feeling super confident, I would be going for this. Okay. All right, so let me show you the fast way. So here's the quick way to do this. I've got my, so I would still come up with my regions the same way that we did a second ago. But I would start off with my polynomial. And can anybody do that thing? Remember, we practiced this a little bit when we were doing polynomials. If I were to multiply this out, what would my lead term in this polynomial be? Think through that. If I were to multiply out x times x times x, there's two of them there, right? So x times x times x times x times x squared, what would I end up with? So my function is x to the 6 plus a whole bunch of stuff, right? We can figure out what that other stuff was, but that's not important because this is enough for me to get my end behavior. So if you're going to do it this way, I want you to write out the word end behavior, and I want you to show me, and you don't have to use limit notation, just show me graphically what the end behavior looks like. You got a positive lead coefficient and an even exponent. What's that end behavior look like? You guys remember how this works? Even means they're both going the same direction. Positive means they're both going up, right? So my end behavior is going to be up on the left and up on the right. Well, if that's the case, then this is plus and this is plus. Okay. Now think about the graph of this thing. If I asked you to visualize the graph, what's the graph going to be doing at -9? Is it going to be bouncing off the x-axis or is it going to be crossing the x-axis? It's going to be crossing. So at -9, we should have a sign change. Agreed? If it's crossing the x-axis, it's either going from a positive to a negative or a negative to a positive. What about a -5? Is there going to be a sign change there? Because that's the thing, we're going to be crossing the x-axis, so there should be a sign change here. And what about at 2? Are we going to be crossing the x-axis there? We're going to be bouncing, so we should keep the same sign. So as I cross this boundary at -9, I should have a sign change. I'm a positive on this side, so I must be negative over here. And I got another sign change here, so I must be flipping back over to positive. And then I should keep the sign change as I cross that last one, which works out with my end behavior. And there I'm done. I got my sign chart all built. So that's a lot faster, right? You don't have to worry about the individual factors. You're just looking at sign changes in the same sign. I would probably, if I were doing this, I would probably also go ahead and write equals 0, equals 0, and equals 0 here. And then everything else would be exactly the same as what we did. I've basically just shown you an alternate way to get our sign chart. Just one that requires a lot less work. Mm-hmm. Yes. So if you're going to do it this way, I want you to write underneath each of your things either same side or sign change. And I want you to explicitly write out end behavior and show me what your end behavior is going to look like. So that's your work. If you choose to do it this way, that's what your work's going to look like. If you choose to do it this way, all your pluses and minuses are going to be your work. Now you want to be confident doing it this way too, because this is going to be, especially when it comes to rational functions, this is going to be my fallback. You can do this with rational functions, but it's a little bit trickier. I think it's a little trickier. All right. Any questions before we do a rational function? Or rational, I guess it's not going to be a function, it's going to be an inequality. Questions? let's go. Yeah, let's do this. All right. We'll start out with a function again, and then we'll turn it into a. You know what? No, let's not. Let's go ahead and make this look like it's going to look in your homework. So we'll start off with greater than or equal to 0. Let's draw our fraction bar. And I need 4 factors this time. So someone give me a factor for my numerator. Nice linear factor. X minus 2 and x minus 2 and x minus 6. And how about for my denominator? X plus 4. Give me something that's going to have a vertical asymptote between positive 2 and positive 6. So x minus something. X minus 3. And I want to square one of these ones in the denominator. Which one do you want to square? The x plus 4? Cool. So we're going to have our key points, and we'll go ahead and draw our number line here. I'm leaving some space above it because we're going to need lots of pluses and minuses again. I'm going negative infinity to infinity. How many key values are we going to want on our number line this time? I'm going to say we're going to need 4, one for each of these factors. Okay, that's where the weirdness is going to happen on the graph. Either we're going to have asymptotes or we're going to have x-intercepts. And both of those things can cause a sign to flip. So we're going to need 4, so I'm going to evenly space 4, which means we're actually going to end up with 5 regions. Agreed? If you've got 4 walls, then that means you've got 5 regions. Oh man, 5 regions. That means we got to do all of this work. I'm getting a little ahead of myself. I should probably write my. Well, we're going to do this in each of our regions, and then I'll go back and label my walls, my boundary points. Let's see, what's the smallest one? Negative 4 is the smallest, right? So it would be positive 6 is going to be the biggest. Negative 4 is going to be the smallest. We've also got a 2 and a 3. This is key. Underneath each of these numbers, I want you to write one of 2 things, either equal 0 or undefined. And negative 4, is this fraction going to be undefined or equal to 0? Negative 4 would cause a 0 in my denominator, which makes it undefined. And at 2 equals 0, right? That's coming from a numerator. That's going to be an x-intercept. So it's that thing is equal to 0 at 2. And in 3, that's a vertical asymptote, so it's undefined. Hey. Yeah, gotcha. Thank you. Get you caught up on this. And at 6, that's in the numerator. That's equal to 0. All right, so 2 vertical asymptotes, 2 x-intercepts. All right, we ready for this? Let's start off with x minus 2. Put your pasta wall up at your important point for x minus 2. I'd say that's 2, right? All right, now think about values to the left of 2. So anything smaller than 2, if I put something smaller than 2 in here, I'm going to get a negative value, right? So that factor should end up negative for anything to the left of your wall. So that factor is negative on the left. And then if I put something bigger than 2 in over on the right here, then this is going to end up positive. So that factor should end up positive for everything to the right of your wall. All right, let's do the same thing with x minus 6. What's my key value there? 6. Put your pasta wall up at 6. And just think through it. Usually it's negative to the left and positive to the right, but just think through it. Sometimes things get screwy because sometimes this will be 6 minus x instead. So just think through. So if I do x minus 6, if I pick something that's less than 6, that is going to give me a negative, correct? If x is less than 6, that's negative. So this should be negative on the left side of our wall. And if I pick something bigger than 6, that's going to be positive. All right, then let's do our x plus 4. That would have negative 4 as its special value. Actually, do I need a special value for this one? It's undefined right here, but I'd say this factor is going to be always positive, right? Unless it's negative 4, we don't have to worry about the boundaries. So because it's squared, it's always going to be positive. So those are all pluses. That's nice and easy. And then x minus 3. Put my pasta wall up at 3 and think through that. If I pick something less than 3, that's going to make that negative. So these would all be minuses. And anything bigger than 3 is going to make that positive. And then we need to work through and think through overall positive and negative. What's the shortcut for positive negatives? Yes. If you have an odd number of negatives, then it's negative. If you got an even number of negatives, then it's positive, right? Because negatives cancel each other out. Whether you're multiplying them or dividing them, they cancel each other out, right? So if you've got even number of pairs, then it's positive of negatives. If you've got an odd number of negatives, then it's going to end up negative. So I see 1, 2, 3 negatives, that's odd. So that's negative there. 1, 2, 3, that's odd. That's negative there. These negatives will cancel because there's an even number, so that's positive. There's a single negative there, so that's going to be negative. Everything's positive here, so that's plus. All right, questions about our sign chart there. Basically the same thing, right? You got to be extra careful when you go beyond this because of the undefined. So no matter what this symbol is, you're never going to include negative 4 or 3 in your solution. Never, ever, ever. Whether it's greater than or less than or greater than or equal to or less than or equal to, negative 4 and 3 are not going to be included. If they end up in one of your regions, they're going to end up with a parenthesis around them. So let's go ahead and do for this particular case. So I'm going to write my solution right up here. Greater than or equal to 0. So we're thinking positives and where it's equal to 0. So not here, and not here, and not here. So equal to and positive. So we got from 2 to 3. And it's equal to 0 at 2. So 2 gets a bracket. Is 3 going to get a bracket? No, it's undefined at 3. It's not equal to 0 there, so that gets a parenthesis. Not here, that's negative, but here, yes, right? That's positive. So 6 to infinity. Does 6 get a bracket? Or equal to 0 at 6. This is greater than or equal to 0. The or equal to 0 part says yes, you get a bracket. Infinity doesn't. Can you guys go ahead and do the case where it's strictly greater than 0? So my fraction is greater than 0. I'm not rewriting my fraction again. Sorry. Feeling lazy. Greater than 0, and then less than or equal to 0, and then strictly less than 0. Here's workout solutions for each of those. I'll do the same. And then we can compare answers. So greater than 0. Let me know if you got questions or if you think I made any mistakes here. I struggled for a little while. I really wanted to include these. I wanted to stick these two regions together. I was like, they're both negative. Is there any way I can stick them together here or here? But I decided eventually they got to be separate regions because -4 can't be part of any solution because it's undefined. So I had to split up. There's no way I could kind of keep these two regions together, even though both were negative, because there's an undefined in between. Questions? Yeah. So I'm going to show you the short version of this, but I'll put the homework assignment up first for those that are feeling ready to get started on it. So give me just a second here. I don't remember it off the top of my head. Thank goodness Canvas is a thing. Oh, I got to update our page. Page 264. 1 to 19 odd, 33 to 43 odd. I'll put this up here, and then I want to show you there is a shortcut to this as well. For those that are interested, this is a little bit, fair warning, this is a little bit trickier to pull off than the polynomials because end behavior is not very straightforward when it comes to rational functions. Is anybody interested in seeing the shortcut method for this? Yes, couple. Okay, so I'll show you. I'm going to set up my number line with those same 4 values on them. All right. Do you guys get a chance to copy that down? Anybody who's not interested in a shortcut? Okay. Here comes the shortcut. All right. You don't have to pay attention if you don't want. But if you're not interested, then just be quiet for a second. So those who are, because this gets tricky. All right, so I've just copied down my number line. The undefined and equal to 0 piece doesn't change. It just matters whether it comes from a numerator or a denominator. So here's the deal. I can go through for x minus 2. That's this one here. Is my graph going to be crossing or bouncing? Crossing. So we should have a sign change at x minus 2 or at 2. There's one other place where I'm going to have a sign change. That's 6. That's a singleton, so we are going to be crossing. Bless you. Now, asymptotes can also have sign changes or not. The rule is kind of the same. If it's an even power, remember, if it's an even powered asymptote, odd powered asymptotes go opposite directions. Even powered asymptotes go the same direction. So even powered asymptotes would not have a sign change. If it's positive on the left, it's positive on the right also. If it's even powered, which this one is. So -4 is not going to have a sign change. So no change. Well, what about 3? It will. That's an odd powered asymptote. So one side's going up, it's a positive, one side's going down a negative. There is a sign change as we cross that. Now, if we think about this function overall, and we try and think about the end behavior, it gets a little bit trickier because what would this be if I multiply? What would my lead term be top and bottom if I multiplied it out? X squared on the top and x cubed on the bottom, which means what's our end behavior? What's the graph doing as we head off to the left and right? It's a rational function. What happens to a rational function? We have a higher degree in the denominator. Y equals 0 would be our horizontal asymptote. That determines our end behavior. So way off to the left and right, it's heading towards 0. Now it's either a little bit above or a little bit below. I can't tell though because it's not clear to me where it is. So this gets a little bit trickier. So somehow I'm going to have to figure out one of my regions by hand. One of my regions I'm going to have to pick a test. And rather than do the pasta wall for this, I would probably just pick one of my regions. Personally, I would pick this region here because what convenient value of x falls between -4 and 2? 0 is awesome, right? 0 is the easiest number to deal with. If x equals 0, then I'm going to do a sign chart just for this piece because once I got this piece, then I got the rest of it. I know my sign changes. So if I plug in 0 for x, that's going to be negative and that's going to be negative. That's going to be positive squared, which will stay positive, and that's going to be negative. So I did have to do one of my regions to figure it out. Overall, that's going to be I think that's going to be a negative region overall. Agreed? And then once I've got that, I can use my sign changes to figure out the rest. So if that's negative, moving to the left, there's no change. So that would be negative. Moving to the right, there is a sign change. Another sign change sends me to negative. Another sign change sends me to positive. So you can use the asymptotes with the sign changes the same way that you do your x-intercepts. Odd power, odd multiplicity asymptotes are going to give you no change. Even multiplicity asymptotes are going to give you a sign change. Sometimes you're going to have to figure out one of your regions the old-fashioned way. But once you've got that, along with your sign changes, then you can fill out the rest. All right. Once again, your homework assignment is that. And I do not have time to check your homework today, so I'll have to get a next class. Yeah, bring it on up here. Anybody who's got assignments for me, if you've been absent or if you've just got old stuff, let's get it in the grade book. What is it? No, throw those pastas away. Can you step over here? Because I got to bring up everybody's grades. Sure, I'm not showing the world. I should probably also stop recording, right? Okay. Stop recording.